Welcome back, everybody. Ready to dive deep today?
Always ready.
Today, we're going deep, literally, into the world of submarine ventilation. I mean, we all breathe, right?
Right.
But imagine being hundreds of feet underwater, stuck in a metal tube.
Yeah, not exactly a walk in the park. Creating a livable, breathable atmosphere in that kind of environment, that's a serious challenge, a real feat of engineering.
And that's what we're looking at today. We've got some fascinating sources lined up, historical accounts, technical breakdowns, and even a comparison of how the US and Russia tackled this problem.
Should be interesting.
By the end, you'll not only understand the science of breathing underwater, but also the incredible risks and innovations that have shaped this technology.
You know, it's really striking, looking back at how basic those early attempts were.
Oh, yeah.
Yeah, before all the fancy systems we have today, it was all manual pumps and air quality that would make a modern-day safety inspector, well, faint.
Our sources actually describe it as a recipe for disaster. Can you tell us a bit more about the health risks those early submariners faced?
Absolutely. So picture this. You're trapped in a confined space, oxygen levels are dropping, and meanwhile, carbon dioxide is steadily climbing.
Sounds awful.
It was. Headaches, nausea, you could even lose consciousness. And sadly, in some cases, it even led to death from CO2 poisoning. Those early voyages were really pushing their luck.
It's amazing they could even function in those conditions. How'd they start to solve that whole oxygen in CO2 out problem?
Well, the development of oxygen generation is a whole story in itself. Early submarines relied on chemical methods, things like sodium peroxide to release oxygen.
So they're literally making a chemical reaction happen inside the submarine.
Exactly, generating heat right alongside that precious oxygen. Worked in a pinch, sure, but definitely not ideal in the long run.
Those early subs must have been pretty toasty with all those reactions happening. So how did they move beyond those first solutions?
The next big leap was electrolytic systems. They basically used electricity to split water molecules into their core parts, oxygen and hydrogen. Much more efficient, able to generate a continuous oxygen supply. Big step forward.
That sounds like something straight out of a spaceship.
You know, you're not wrong. Creating a breathable atmosphere in a closed environment, whether it's a submarine or a spacecraft, faces very similar problems. And these fields have often borrowed tech from each other. The electrolytic systems on modern submarines are surprisingly similar to the ones on the International Space Station.
Wow, that's a great comparison. Okay, so we've got oxygen flowing, and what about getting the CO2 out? You can't exactly hold your breath for months at a time down there.
Well, first they kept it pretty simple. They used things like soda lime, which absorbs CO2, like a giant air filter.
Makes sense.
But those had a limited capacity and needed to be replaced frequently.
Then things got a little more advanced, right?
Oh, yeah. Later systems use these things called molecular sieves. Basically, they're tiny porous structures, amazing at trapping CO2 molecules, much more efficient removal from the air. Think of it like a sponge, but on a molecular level, designed to soak up that carbon dioxide.
So a kind of molecular filtration system. Pretty neat. Now, our sources also mention that Soviet submarines had a history of pressure-related issues, sometimes with disastrous consequences. What was going on there?
That's the million-dollar question. Historians and engineers have been puzzling over that for decades. No easy answer. But our sources point to a few likely culprits. First, there's the design itself. Some Soviet subs might have had some fundamental flaws in their hull or ventilation systems.
So seawater could seep in, leading to a pressure buildup.
Exactly. Bad news at those depths. And then there's the materials used. Early Soviet subs often used lower-grade materials compared to their American counterparts, more prone to corrosion, weakening of those critical components, again leading to potential leaks and pressure buildup.
So we've got design flaws, material weaknesses, anything else that could have caused these pressure issues.
But we can't forget about the human factor. Improperly operated equipment or maybe just not following procedure, that could definitely play a role. Just goes to show, even with the most advanced technology, human error can have some serious consequences.
Design flaws, material weaknesses, and human error. It's like a detective story. But instead of a whodunit, it's a what caused it.
And like any good mystery, it could have been a combination of things. What's clear is that those recurring pressure problems were a huge wake-up call. Highlighted the danger of submarine technology. Every time they went down, it was a gamble against the crushing pressure of the deep, and the consequences of failure were very, very real.
It sounds like those pressure problems really hampered Soviet submarine development for quite a while. Their American rivals were taking a different approach, though, right?
Yeah, the Americans were all about cutting-edge tech and high safety standards.
Makes sense.
Sometimes that meant they had to sacrifice speed or the number of submarines they could build.
So, a real difference in priorities. The U.S. focusing on quality and safety, while the Soviets...
We're grappling with those design and material challenges we talked about.
Fascinating comparison. Two superpowers, locked in a Cold War, both trying to conquer this life-or-death challenge of breathing underwater, but with very different approaches.
A real clash of philosophies.
And that's exactly what we'll be exploring after a quick break. Don't go anywhere. We'll be right back to delve deeper into this amazing world of submarine ventilation. Welcome back. So before the break, we were talking about how the U.S. and the Soviet Union took such different approaches to submarine ventilation.
You know, it's interesting. Despite their differences, both nations ended up making incredible progress.
Ooh, yeah.
Yeah. The Soviets, even with their setbacks, they developed some pretty impressive ventilation tech. And by the modern era, both countries were using pretty similar systems, scrubbers, advanced control systems, the whole works.
So even with the rivalry, the tech kind of converged.
I think it just shows how universal the challenge is. When you're talking about keeping people alive underwater, some solutions are just plain better, no matter what your ideology is.
Makes sense. It's like the need to survive trumped the whole political divide. So this convergence of technology, it's a testament to human ingenuity, right?
Absolutely. And it raises a question I think our listeners might find interesting. Imagine you're on a modern submarine, hundreds of feet below the surface. What's it like to breathe down there?
Yeah, what's the air like?
You might be surprised. Thanks to all those advancements we talked about, the air you breathe on a modern submarine is actually really fresh and clean.
No kidding.
Yeah, often better than the air in a lot of cities.
So no more hand-cranked pumps and chemical reactions, giving everyone a sauna experience.
Nope, gone are those days. Today, we have these super precise gas analysis systems, constantly monitoring the levels of oxygen, carbon dioxide, and all those other trace gases.
So they can keep the air quality in a safe zone.
Exactly. They're incredibly sensitive, very reliable, and they feed all that data into sophisticated control systems.
To regulate the whole environment.
You got it. Temperature, humidity, airflow, the whole 9 yards. And they can adapt on the fly, respond to changes in crew activity, environmental conditions, even potential leaks.
Wow, so it's like the submarine has its own lungs and circulatory system, always adapting to keep the crew alive.
That's a great way to put it. And you know how our bodies have backup systems? Modern submarines are the same way. They have extra oxygen generators, spare CO2 scrubbers, all sorts of backup components.
So if one thing breaks, there's a plan B.
Exactly. Gives the crew time to fix whatever problem comes up. Of course, all of this takes energy, so modern subs have to use really efficient parts too to keep the power usage down.
It's incredible, really, transforming such a harsh environment into a livable space. But even with all these advancements, there's still some risk, right?
Of course. Submarines are complex machines operating in a very demanding environment. Even with the best tech and the most experienced crew, something could always go wrong.
So never take it for granted. Always got to respect the power of the ocean. We've come a long way from those early, clunky systems, but the challenges of breathing underwater are always there.
Absolutely. And as we keep pushing the boundaries of underwater exploration, those challenges are only going to get tougher. Which brings me to a question for our listeners. Imagine you're designing the next generation of submarines. What kind of innovations would completely change how we breathe underwater? What would make today's systems look like those old hand pumps?
Yeah, what could really revolutionize things?
Maybe a system that copies marine life, extracting oxygen straight from seawater.
Ooh, I like that. Or maybe some kind of bioengineered solution. A partnership with algae or bacteria, something that makes oxygen as a byproduct.
The possibilities are really exciting, aren't they?
It's mind-blowing. What if we could build underwater habitats that aren't just livable but completely self-sufficient, mimicking the ocean's natural ecosystems?
Now that's a fascinating concept. Blurs the line between technology and nature. Might sound like science fiction, but think about it. 100 years ago, the idea of living underwater for months in a comfortable, breathable space would have been crazy. Now, thanks to human ingenuity, it's a reality.
It really makes you wonder what the future holds.
Absolutely. What seems impossible today could be commonplace tomorrow.
You know, we've focused a lot on oxygen and CO2, but there's another aspect of submarine ventilation that our sources barely touch on.
Oh.
Air purification. It makes you wonder how they dealt with stuff like dust, bacteria, and other contaminants in the air. You're breathing in that same air for months. I can only imagine how much dust, bacteria, and other stuff could build up.
Yeah, it's not something you want to think about too much,
Right.
but it's super important for the crew's health in the long run.
Absolutely. So how did they approach this challenge?
Early on, pretty basic stuff, simple filters, even things called electrostatic precipitators to trap the bigger particles.
I see.
But as subs started spending longer and longer underwater, they needed something more heavy-duty.
Yeah, I can only imagine how hard it must be to design a good air purifier for such a small space.
It was definitely a challenge. It had to be efficient, small enough to fit, and it couldn't use up too much power. Oh, and it had to work in a really humid and corrosive environment.
Sounds tricky. So how'd they pull it off?
Over time, they developed some really clever filtration systems, things like HEPA filters and activated charcoal.
Ah, I know those.
Yeah, they can remove a whole bunch of different contaminants, dust, pollen, even bacteria and viruses.
It's funny, it seems like these underwater innovations kind of mirrored what was happening with air purifiers on land.
Exactly. A lot of the tech we use in air purifiers today has roots in submarine ventilation. It's a perfect example of how a really specialized environment can drive innovation that ends up helping everyone.
It's amazing to think about, that tech we take for granted in our homes might have started out in a submarine.
It's pretty cool when you think about it that way.
So as we wrap up our deep dive into submarine ventilation, what are the big takeaways for our listeners today?
Well, I think it's important to realize just how much ingenuity it took to create a breathable environment in such a harsh place.
Yeah.
It's not easy being underwater. From those first primitive systems to the incredible life support tech we have today, the story of submarine ventilation is a testament to human innovation.
It's also a good reminder to appreciate something we usually take for granted: breathing. We don't often stop to think about all the complex systems that give us clean, breathable air, whether it's on a sub, in a spaceship, or even just at home.
And, as we keep pushing further into the depths of the oceans and maybe even beyond the challenges of breathing in these extreme environments, are only going to get tougher.
Makes you think, huh?
It does. It really underscores the importance of science and engineering, pushing those boundaries so we can keep exploring safely.
Maybe someday we'll be able to create underwater habitats that aren't just livable, but actually thrive as part of the ocean's ecosystem. Wouldn't that be something?
Now, that's a goal worth striving for. It reminds us that the pursuit of knowledge and exploration can lead to breakthroughs that benefit all of humanity. Who knows what we'll discover next?
Well, on that note, we've covered a lot of ground today, from the history of submarine ventilation to the mind-blowing technology that makes it possible. Hopefully you've come away from this deep dive with a newfound appreciation for the air we breathe and all the effort that goes into making sure we have it.
It's been a fascinating journey, exploring the ingenuity, resilience, and that constant drive to explore the unknown.
And if you're interested in diving even deeper into this topic, there's a ton of info out there. Check out some books, explore online. There's always something new to learn.
Absolutely. The more we understand about the challenges of breathing underwater, the better prepared we'll be to tackle the challenges of exploring our oceans and beyond.
Well, thanks for joining us on this deep dive. Until next time, keep exploring, keep asking questions, and most importantly, keep breathing.